Hi, team. Welcome to some wonderful Math Wednesday work. I'm going to answer all the questions on the mock test. It's a 136. I predict talking about all these questions is going to take me about half an hour, but we'll see. I expect I can get it done before the end of the day. Okay, so the first thing to take a look at is the rubric. Level 4 means you're doing things with like very few errors or no errors and lots of clarity of communication, particularly when you're representing things as percents, decimals, and fractions, and you know how to convert between those three things. That's one skill that we're going to measure. Operations with integers. Operations mean add, subtract, multiply, divide. Okay, can you do that with integers with no errors, occasional errors, etc., etc.? Okay. Operations with fractions, percents, and decimals is the main thing for this unit. Can you do that with no errors and the ability to solve challenging ratio questions as well? And then can we apply these rational numbers in different situations? Can you apply them with accuracy and extend your thinking into these different situations using these mathematical tools? Finally, order of operations is BEDMAS. Do you follow BEDMAS or do you make mistakes? If you follow BEDMAS, you're not making mistakes. So make sure you follow BEDMAS. So let's do it. Okay, so first thing that I do with a question like this is read it and say, all right, I know that we're talking about January 10th, 1960, but I want to know what's the highest temperature reached and the final temperature. So these numbers, I don't need them. But this I need. Negative 19. Okay, so there's a typo there. Okay. Negative 19 degrees is our starting point. So we start at negative 19. In 1 hour, the temperature rises by 41 degrees. And then the next day it drops to 32 degrees. But let's find out what this is. Negative 19 plus 41. So negative 19 plus 41 it would be the same thing as writing 41 minus 19. Okay, and that's going to give us the final temperature. So 1 minus 9 can't do it. 11 minus 9 is 2. And then I have 3 minus 2 is 22. So it goes up to 22 degrees in an hour from minus 19. Like a very cold day to a nice warm day in the summer. This happens in Calgary. That's crazy temperature swings. All right, and then the next day it drops by 34 degrees. So we're going to go 22 minus 34. Well, 34 is bigger than 22, so I know my answer is going to be negative. All right, if I have a positive number, positive 22, and I subtract a negative number, then I don't know if the answer is going to be positive or negative. If I had 22 subtract 5, then I'm going to have positive 17. If I have 22 subtract 34, well, then I have negative 12, because here's 0, here's 22. And if I count 22 steps and then I count to 34, 35, 36, 37, 38, 39, 40, 41. That was weird. Why did I say it that way? Okay, what am I trying to talk about here? What I'm saying is, if I start at 22 and I take 22 steps here, this is 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. I need to count these steps, and that's how many it goes into the negatives. It happens to be negative 12 because I did the math. I don't have to count my steps. But if you need to, you can just think about a number line and do this. So it goes down to negative 32, only to rise again by 13 degrees the next day. So I go negative 12 plus 13. So if I add 13 steps here, I would take away these 12 and add 1. So that would get me to positive 1. Okay, so the final temperature is 1. Now for a question like this, give a sentence answer. All right, so I would say the highest temperature, high has an H in it, was 22 degrees. The final temperature temp was 1 degree. 22 degrees there. Okay, so now evaluate the following without a calculator. Okay, don't mind if I do. Minus 3 plus minus 9. All right, so you want to think about this as starting at 0. I start back here at minus 3. That was my first move. So I went minus 3. Then I add a negative motion of minus 9. So I go 9 further in that way. Another minus 9. So that's minus 12. So negative 3 minus 9 equals minus 12. Okay, so there we go. That's that one. 5 minus 13 is minus 8. I start at 5, I go backwards 13, I'm minus 8. 7 times minus 4. A negative times a positive gives me a negative, so this is negative 28. And negative 36 divided by 9 is an ugly way of writing this question. Write it this way, negative 36 divided by 9. And then you can write 36 in a new way. You can write that as 9 times 4 divided by 9, and these 9s would cancel. Gives us our answer 4. Wait a minute, no it doesn't, it's negative. Okay, so the answer here will be negative because we have one negative in there, so the answer is negative. Multiplying and dividing, you just count up the negatives, and if it's odd, if it's 1, 3, or 5 negative signs in your multiplication question, you'll have a negative answer. If it's even, you'll have a positive answer. There we go. That's the answer. That's the answer. That's the answer. Keep going. Okay, determine the value of the following without a calculator. 3 minus 1 is 2, 1, 0. Okay, so the way I do this, some of you said this. I look at that, and I see that this is 4 times 2. Very good way of looking at that. And this is 4 times negative 1. Okay, and then I'm going to add them. Let's put a bracket around our negative 1 there. 4 multiplied by negative 1 plus 4 times 2. And then this is 3. We'll say 3 plus that, because it's 3 plus negative 4. Okay, so that's one way to do it. Or you can just add together. 3 minus 1 is 2. 2 minus 1 is 1. We're at 0. We're at minus 1. And then we add 4 2's. That's add 8. So we get 7. So this is 3 plus negative 4 plus 8. 3 plus negative 4 is negative 1 plus 8 is equal to 7. There, final answer. This one here, we got to do bedmas. Okay, so now we get into some bedmas questions. This indicates multiplication. This indicates multiplication. Okay, and those happen first. There's nothing to do inside the brackets, so we don't have to worry about it. First one, negative 5 times 8 is negative 40. Negative 2 times negative 3 is 6. So we have negative 40 plus 6 is equal to negative 34. Okay. This is a fraction in 5 parts, so that's 1 over 5, because one part is shaded. Here, 6 parts are shaded, and there's 8 parts, so we would say that's 6 over 8. Or, even better, 3 over 4. 3/4 of these are shaded. Now, let's put these on a number line. And there's a tricky one, because there's a decimal there, and the rest are fractions. How are we going to compare that? Well, let's put 0. Okay, and let's say which ones are less than 0? Well, the negative ones. They'll be the most least. Which is a bigger negative? 1.5 or 5 over 4? Think of this as having 5/4 in your pocket. You have $1.25. This is $1.50. Okay, so this one is bigger. So we will go negative 1.5, comma, negative 5 over 4, comma. And then we'd have 0 and then comma. 0 is not on the list, but I just added it for reference. All right, now the smallest one that's left. Okay, so what's left? We have the 3 positive ones. Let's highlight them. This one, and this one. Thirds are bigger than sixths. 2/6 is equal to 1/3. So 1/6 is clearly less than 1/3. So 1/6 would be next, and then 1/3. But then how about this 7/9? Well, 1/3 would be equal to 3/9. 7 is bigger than 9. So 7/9 is bigger than 3/9. Here's 3/9 here. 2/6, then you wonder what that is in ninths. It's 1.5 So don't ask for that. It's like 3/18 or something. Is it? No, 6/8. 1/6? Yeah, 1/6 is 3/18. Yeah, so it's actually 1.5 So that would be weird. Okay, anyway, keep going. This is easy. 3/8 plus 1/8 is equal to 4/8. 4/8 is equal to 1/2. Okay, 4 is half of 8, so that's 1/2. All right, 5 over 12 times negative 4 over 5. There's the long way. I'll show you the long way. Top times top. 5 times negative 4, negative 20. Bottom times bottom. 20 times 5, 60. 20 over 60, 2 over 6, 1 over 3. Easy way. 5 cancels 5. Oh, sorry, this is negative 1/3. 4 and 12. I'm going to rewrite 12 as 3 times 4. So that cancels this 4 up here. So this is equal to, this cancels away to 1. So it's -1 over 3. Okay, I just do it by canceling right there. And if that confuses you, do it the long way and reduce your fraction. 4/5 minus 3/4. Well, we got some doing to do here. Okay, so let's do some doing. First, we need to get a common denominator. And I see that I need to make that common denominator 20. All right, so 4 over 4 times 4/5. Well, that's going to be 16 over 20 minus 3 times 5 is 15 over 20. 16 over 20 minus 15 over 20? It's very small, isn't it? Yes, it is. It leaves us 1/20. So this is showing us that the gap between 4/5 and 3/4 is very, very narrow. If someone says, I want 3/4 of your money, and you say, well, here, no, I'll give you 4/5 of it, it's almost the same. All right, here's another way of thinking of it. 3/4, 75 cents. 4 over 5 as a decimal is 80.8. Okay, so that's 80 cents. Scale that up, it would be 8 over 10. Okay, that's 8 dimes. A tenth of a dollar is a dime, so 80 cents. The difference between 80 cents and 75 cents is 5 cents. It takes 20 nickels to make a dollar. There's your 1 nickel difference. Carrying on, 3 over 13 divided by 9. Well, it helps if we write 9 as 9 over 1, because now it's a fraction, and now I can do this as a multiplication question. So let's make a multiplication. This is 3 over 13 times 1 over 9. Multiplying by 1/9 is the same thing as dividing by 9. Flip the fraction and multiply. Okay, so this is the 3 cancels one of the 3's and the 9 and makes it 3. 3 times 3 is 9, so I can cancel one of those 3's with that 3. And I end up with 1 over 13 times 3 is 39. So this is 1/39. So 3 over 13 divided by 9 is 1 over 39. And that makes sense to me. If it doesn't make sense to you, then come and ask me about it. All right, let's do this one, everyone. 37 minus 5 times 3 plus all of this. Okay, so let's say this is equal to, I got to leave that alone. I can't do anything to it until I do this multiplication. -5 times 3 is -15. Plus, well, all this stuff. Okay, well, let's see. I can cancel 5's here, but I have to remember there's 2 5's up there. This is what I would do. 3 times 5 times 5 divided by 5. Okay, and I'm adding this. This 5 cancels that 5. So I have 3 times 5 is 15. All right, so this is equal to 377 minus 15 plus 15. Minus 15 plus 15 is 0. So this is equal to 377. Now, the important thing here is bedmas, okay? First thing that happens is this exponent. There's actually no brackets, so we don't have to do any brackets. We'll be saying, well, the 3's in brackets, the 5's in brackets. Yeah, the 3's in brackets, but I can't do anything in the brackets. It's not like it's 2 plus 1. If it was 2 plus 1, then yeah, I'd have to do that before I multiply. B, and then E is the next thing. So I have to do that exponent first, and I did. I expanded it as multiplication. I can't bring this 3 in and multiply and then have 15 times 15, because then I have an extra factor 3 that I'm not supposed to have. And then D is division, and M is multiplication, and these can happen in any order. So cancel is the division. 3 times 5, 5 times 3, these are the multiplication. And then we do the AS. Then you do the addition and subtraction. Minus 15 plus 15, that is 0. So this goes to 0, and then it's just equal to 377. Mitchie Marner. Let's check. Let's see what his stats are right now. I think he might have scored last night. It's certainly he had an assist. So let's go check. So this is how you check. You type in NHL, ESPN, and then you go to their stats. Okay, this is where I get my hockey stats. ESPN's website. I find it's the easiest website to navigate. So go in here to stats, and then go to. He would be in, if we just click on Austin Matthews, we can go to Toronto. Oh, this is taking a little longer than I thought it would. I should have paused for you. And then, there he is, Mitch Marner. Oh, it moved on me. There we go, Mitch Marner. So here's his career, okay? His career in 403 games played, he has 420 points. Oh, wow, 420. And it's 126 goals to 294 assists. That's fairly close to 5 over 12. I chose 5 over 12 because it's close enough, and I like those numbers. This year, he has 23 goals and 39 assists. 23 goals. So he did score last night. Okay, when I created the test yesterday, he only had 22. All right. So anyway, let's go back to the question, Mr. Jennings. So we know that he gets more assists than he gets goals in a ratio of about 5 to 12. So if I said if he scored 1 goal, how many assists would he have? Well, I can tell it's be bigger than 2, but smaller than 3. Because if this was a 10, then he would score 2 assists for every 1 goal. If this was a 15, it would be 3 assists for every 1 goal. But because it's in between 10 and 15, I know that it will be between 2 and 3, the amount of assists he gets per goal over his career. So how many assists would that be? Actually, it's 12 divided by 15. Sorry, 12 divided by 5. This is assists divided by goals, and that's equal to 2.4 assists per goal. Assists per goal, okay? And so if I know that he gets 2.4 assists per goal, and I know he's scored 22 goals this year, and I multiply this by 2.4, this is A over G, G on the bottom, so your units are assists over goals. This is assists over goals, okay? If I multiply 22 goals times 2.4 assists over goals, notice that goals, the unit cancels, and I get 22 times 2.4 assists. The units even guide me to the correct answer because this is a number of assists divided by number of goals. It's assists over goals. The goals cancel and leave me assists. So 22 times 2.4 equals 52.8. And we would expect him to have 52.8 goals so far this year. He does not. He has fewer than that. Is that good or bad? Well, he has 39 so far this season. And that's significantly less than 53. What that's telling me is right now his rate is a little bit better than 1 goal every 2 assists. It's better to score goals than to get assists. So he's actually scoring more goals than we would expect. If you look, he still has more points than games played, so his overall point production's at the same pace. He's just scoring more of them as goals now. So he's changed his game a little bit. Okay, now we want to find out who's the faster hot dog eater. Okay, so this is 75 hot dogs per 10 minutes. Okay, that's for Joey Chestnut. All right, and so that's 7.5 hot dogs per minute is what's he eating. Miki Sudo, who is the women's champion, I think she probably took 10 minutes as well, but I changed this to make it mathematically more interesting. Ate 48.5, but I said 49 because why not? Divided by 6 minutes. 49 divided by 6 doesn't reduce nicely into a decimal, so I have to kind of just figure that out, what that is. It's like 0.8 or something. So if I want to convert that to a decimal and compare it, I would go 49 divided by 6 gives me, no, you do 6 to, what did I write down? 49 hot dogs. Yeah, no, that's right. 7.5 hot dogs per minute, and hers was 8.1 hot dogs per minute. So that's right. Yeah, she's eating 8 hot dogs a minute. He's only eating 7.5. 8.1. She eats hot dogs faster. Hot dogs per minute. Okay, so it's like kilometers per hour in terms of the unit, but in this case, it's hot dogs per minute. It's a lot funnier to imagine. They eat fast. You knew that already. Okay, now solving for these unknowns is not as bad as you might think. Okay, so here, x is 15. Wait, is it? No, 18. It's 18. How do you do that? All right, well, here to find out what x is, let's not divide by 36. Let's then multiply both sides of this equation by 36. So I'm going to multiply over here by 36, okay? And then I'm going to multiply over here by 36, all right? Oh, yeah, so I said, this is half. And so if I multiply both sides by 36, this cancels, that cancels. That's why I did it, to isolate x, to get it alone. 12 over 24 is a fancy way of saying 1/2. So I could just reduce that fraction, okay? And then a half times 36 is 18. So that's one way to get to your answer. Another thing I can do here is just work it out. 12 times 36 is 3 times 144. 3 times 144 is 432. I think it's 432 divided by 24, which happens to be 18. Okay, it's 18. All right. You could also say, well, maybe I don't spot the 12. No, I spot it. Okay, this is 1/2 times 36. 36 divided by 2 is 18. Okay, it's 18. Just let me have it be 18. You can also do that on a calculator. 12 times 36 divided by 24 will tell you it's 18. Okay, so x is equal to 18. Done, final answer. Sorry, talking a lot about not much. This one, there's an easy way and a useful way. Okay, the useful way is going to work in situations like this. The easy way is to notice something. I can scale this fraction up here by 5, and the top will equal the top. Then the bottom must equal the bottom. And then that would be a. Okay, so let's do that. All right, I'm going to multiply here top and bottom by 5. 5 over 5 times 1/6 equals 5 over 9. I'm going to bring my equal sign down in the middle. So it's going to be 5 times 1 is 5, over 5 times 6 is 30, is equal to 5 over a. 5 divided by 30 is the same as 5 divided by some number? Well, some number must be a, so I would say 30 equals a. There, done, final answer. Okay, now there's another way to do this one, and it looks like this. I'm going to copy it up here. 1 over 6 equals 5 over a. Okay, let's get some space. First thing that I'm going to do is I'm annoyed that my unknown is on the bottom. Okay, it's a little harder to solve when it's on the bottom. So what I'm going to do is multiply both sides by a. I multiply by my unknown number. I'm allowed to do that. It's a. I don't know it yet, but it's a. Whatever it is a. A cancels a, so I'm left with a over 6 equals 5. I don't want it over 6, so I'm going to multiply both sides by 6 as well. 6 times this and 6 times this. Okay. Now this 6 cancels that 6, and I'm left with a times 1 on this side. A equals 5 times 6 is 30. Okay. So I want to lay that out again for you. I'll do it with this one in just a second. So you'll see me answer this one with the same method. And it's an uglier question. So hopefully that helps you. This one here, k divided by some numbers equals 7 over 3. Okay. So what I'm going to do is multiply both sides by 7. Okay. And then this 7 cancels that 7. 7 times 7 is 49. So 49 divided by 3 is equal to k. That was what I was asked to find, was k. And there it is. That's the answer. All right. Now, with this one, 31 over 5 is equal to 10 over v. Okay. This number is a little bit more than 3 times that number. So I expect this number to be 3 times smaller than this number, kind of like 5 divided by 3. Yeah, 3 times smaller. 5. Yeah, right. So, wait, what? I'm confused. Anyway, I don't need to be confused. Yes, that's correct. So it's a little bit bigger than 1, a little bit smaller than 2. Now, how do I solve this for v? Well, my first step would be I am going to multiply both sides, top and bottom, by v. Okay, and I'll write that out as another line for you. I'm actually going to zoom in on this problem and get my face out of the way. Come on, zoom. Where are you? Zoom. There you go. Oh, it's really zoomed in. That's beautiful. Okay, so I multiply both sides by v. Get my face out of the way. Send me over to the other side. There we go. It's sunny in here. So this v on the bottom cancels that v on the top. And I'm left with this as my next line here. It's going to be 10 is equal to 31v, 31 times v divided by 5. All right? This is just this multiplied by v. I put the v over there because I'm going to put something over here. Now, I don't want to divide it by 5 and then multiply it by 31, which is what this fraction is telling me to do. It says divide v by 5 and then multiply it by 31, you'll get 10. Okay, so what I'm going to do is I'm going to multiply both sides by 5, and I'm going to, so let's multiply by over here by 5 times 5, but I'm also going to divide both sides by 31. because the opposite of multiplication is division. So I'll put that down there. The opposite of division is multiplication. So I'll put that up there. 5 over 31 times 31 over 5 is 1. Anything times its own flipped fraction gives you 1. The 5 cancels the 5. The 31 cancels the 31. This is 1v. So I'm going to find what v is. 5 over, this is 31 there. So I have to multiply the same side both things. V is equal to 10 times 5, which is 50, over 31. These don't share any factors, so that's done. Yeah, let's keep going. All right, so now I'm going to zoom out again. There we go, that's better. Complete the chart. Some of you said you don't like charts. Okay, whatever. What this means is show me an equivalent decimal. So what I do is I divide 3 by 5 on my calculator, and I find that it's 0.6. 0.6, okay? So this is 0.6 as a decimal. As a percent, that's 0%, okay? To change a decimal to a percent, you got to go once, twice. Put the decimal there, make it the 0, okay? But we don't need to write the decimal that way. 0.6 is fine, okay? Now, 0.14. This is 14 100ths is equal to, well, I see that they both share a factor 2. 7 over 50. I divided the 2 out. So now it's 7/50s. 7/50ths. Okay, as a percent, it's 14% because I moved the decimal. Okay, 64%, that's 0.64. Let's write that as a this here, 64 over 100. Here I spot they're both divisible by 4. So 64 divided by 4 is 16. So I have 16 over 100 divided by 4. Well, 4 quarters. Well, a quarter is 25. There, 16 25s. All right, 3 1/7. 3 1/7 could be written as, this is equal to 3 times 7 is 21, plus 1 is 22/7. Check it on your calculator. Put these both into decimals, and you'll see that that's true. I took 3, I multiplied by 7. So this 3 is like 21/7. Then I add one more seventh to get 22/7. Okay, now as a decimal, 22 divided by 7 is not something I can do in my head. No. I know it's going to be bigger than 3 and just a little bit bigger than 3. It's 3.1 something. 3.142857. This is an approximation of pi, Mr. Daviau. Very good. 3.14. We're going to write down 3.14 as a decimal. It's very close to pi. And as a percent, that's 314%. That's saying the circumference of a circle is 314% longer than its diameter. Okay, the decimal here, 2.125. This is 202,125 over 1,000. Because this is the thousandths place, so I need to use 1,000 as my denominator. That really looks to me like it's divisible by all 3 of the 5s. Yeah, I think it should be. So let's see. I'm not in the mood to work through that in my head. So I'm going to do this. 2, 1, 2, 5. Why am I not in the mood? Because I just finished 3 periods of math. You guys just finished 1 and you're all tired. I have to go divide by, I'm going to divide this by 5 times 5 times 5, which is divide by 125. Equals 17. Okay, so, and this one down here is also divisible by 5 times 5 times 5. It's going to be 8. So this is equal to 17 over 8. So you can use your calculator to help you reduce these fractions as well. I spotted that they're both divisible by 125. If you can't do that, you can spot that this is 10 times 10 times 10. Okay, and that could be grouped as 125 times 8, because each 10 is 5 times 2. So group the 2 times 2 times 2 times 2 as 8, and group the 5 times 5 times 5 as 125. 125 times 8. This was divisible by 125. It happens to be 17 of them, and so we get 17 over 8. Okay, as a percent, it's 212.5%. Move the decimal place twice. Okay, this one is 1.32, and then that's 132 over 100. Both are divisible by 4. This doesn't have any factors 5, so that's all that's going to come out. And so 132 divided by 4 is 33. Okay, so that's equal to 33 over 25. Your calculator will tell you so. Still smiling somehow after all of that hard work. All right, 5/6 minus 7/8. 7/8 is almost exactly the same thing as 5/6. This is going to be very close to 0. 7/8 is slightly, ever so slightly larger than 5/6. So I'm going to make a prediction that this is going to be 1/24 smaller than 0. Okay, let's see if I'm right. I notice that I need to create a common denominator here. In order to do that, I'm going to zoom in, move this, bring it there. Okay, here we go. All right, I'm going to multiply. If I notice that I can multiply something by 6 and get 24, that's great. The answer is 4 over 4. Okay, and then I need to multiply here 3 over 3. Where did those numbers come from? I noticed that 6 can multiply up and become 24. 8 can multiply up and become 24. All right. Here's another way to think about it. 8 is 2 times 2 times 2. 6 is 2 times 3. Okay, so this has an extra 2 factors too, and 6 is jealous. We need to add those 2 factors. So there's the extra factors too. 6 is 2 times 3. 8 is jealous of 6. 8 wants to have a factor 3. Okay, so you just add the missing factors as though you're trying to please children. Okay, so this will be 20 over 24 minus 7 times 3 is, there it is, folks, 21 over 24. 20 minus 21 is negative 1. This is negative 1/24. Oh, my guess was really, really good, wasn't it? Okay, now let's do this one. This one rightfully confused many people. First, let's convert this to a improper fraction because mixed numbers are gross, okay? So this is what I do. I know that the whole thing is negative. Okay, let me draw a picture of it. Here is 0. Here is negative 1. Here is negative 2. Here is negative 3. And a little bit. Okay, that's 1/5. This is negative 3 and 1/5 here, okay? It's negative 3 and one more piece, okay? It's how many pieces? Negative. Let's look at it. I'll draw my things here in orange so you can see them clearly. 1, 2, 3, 4, 5. That's divided into 5. 1, 2, 3, 4, 5. That's 10. There's 15, and then another one, 16. Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 fifths. And they're all negative. Okay? So what I think of is I just put this whole thing in here. I remember 3 and 1. These are both negative, but I'm going to put this in brackets and worry about it being negative later. And then what I do is I say 3 times 5, that's 15 fifths. Plus 1 over 5, but it's negative, and I'm going to divide by 4/5. Okay, here I'm going to divide by 4/5. Wait, division is the same as flip and multiply. So now this is 16 fifths times 5 over 4. This is equal to negative 16 over 5 times 5 over 4. Okay, cool. All right. Now, you can do this, and 16 times 5 is 80, and that's negative 80 over 20. You can do that, negative 80 over 20, and then you do that on your calculator, and it tells you it's negative 4. All right, but I think you're wasting your time. No, you're not. You're just being careful and doing it step by step. You can cancel the 5s. The factor 5 is going to end up on top. You know that. The factor 5 is going to end up on the bottom. You can cancel this 4 with one of those 4s. 16 divided by 4 is 4. Here's your answer, negative 4. Okay, everything else canceled away to 1. I removed a factor 5 and I removed a factor 4 that were extra. Here they are here, 20. They're extra. They're not necessary, okay? They're going to cancel out anyway. So why not cancel them there? It makes it easier. You don't have to multiply them in, then divide them out. But maybe you get confused doing that. And that's fine. If you get confused, do it the way you're solid on. Come on. Unzoom. Unzoom page. There we go. Evaluate. Please show your work or explain your thinking, the steps you take to find the sum. Okay, so we want to sum this together. We want to add her up. Oh, I'm over time. I need to speed up. Oh my goodness, I thought I was almost done. Okay, soon it's going to be ding dong. All right, 5 over 2 times 3 over 5, right? First I do brackets, all right? Bedmas, brackets first. Inside the brackets, this multiplication happens before that addition. This 5 cancels that 5. So that's already enough. And then 3 and 2. So this is 3 over 2 plus 2 over 3. So I'm going to write this as 2 over 3 plus 3 over 2. That's what's in the brackets. Divide by 5 over 6. All right. Plus 7 over 10. Okay, so now let's do this. 2 over 3 plus 3 over 2. I'm going to need to create a common denominator to do that addition. So this is going to be multiply by 2 over 2, because that's the factor 3 is missing. Multiply this by 3 over 3. So I get 2 times 2 is 4, 3 times 3 is 9. 9 over 6 divided by 5 over 6. So let's write that. This is equal to 9 over 6 divided by 5 over 6. But why would I write it that way when I could just flip it and multiply? Times 6 over 5 plus 7 over 10. I'm not ready to work on that one yet, right? 6 cancels the 6. Easy. 9 over 5 plus 7 over 10. All right, let's just bring this up here. 9 over 5 plus 7 over 10. Okay, scale this one up with a factor 2. 18 over 10 plus 7 over 10 equals 25 over 10. Remove the factor 5. 5 over 2. Done. Final answer. Can't be reduced any further. Leave it like that if you are a sane person or sane mathematician. Change it to 2.5 if you're a maniac. All right. Leon's parents, they allow her to watch television. She can watch as long as she wants, but she has to do math practice. If she watches 5 minutes of television, she has to have done 4 minutes of math practice. You have to eat your dinner before you have your dessert, folks, in life. So, if she's finished 65 minutes of practice already, how much more does she need to practice so that she can watch Spider-Man No Way Home? 2 hours and 28 minutes. Okay, so let's set up some ratios. 2 hours and 28 minutes. That's 120 minutes plus 28 minutes. 2, some amount of homework should be equal to the ratio 5 to 4. Okay, so this here is 148 over homework is equal to 5 over 4. But why'd you set it up that way, Mr. Jennings? Why not set it up this way? Homework over 148 is equal to 4 over 5. Just flip both of them. And then I'm going to multiply both sides by 148. And that's the total amount of homework she needs to do. Homework is equal to 4 times 148 over 5. 4 times 148 equals 592 divided by 5 equals 118 minutes. She needs to do basically 2 hours of math practice, okay? Is basically 2 hours of math practice. Notice I rounded, and I rounded to the nearest hour because I'm a sane human being. I don't care about 2 minutes. I'm just going to finish my 2 hours of math practice and then go watch my movie. And then my mom's going to give me a high five. I'm not going to negotiate the extra 2 minutes, okay? It's not worth it. All right, so if she has to do 120 minutes, but she's already done 65 minutes, therefore, she needs to practice 55 more minutes. And if you said 53 minutes, you just wasted your and your mom's time arguing about 2 minutes, okay? Just do it 55 minutes. All right. So last question. I'm a little over time, but here we are. Okay. At the end of the busy lunch hour, same size pizza only has the following pizza left for sale. This looks like 5/6 to me, and this looks like 9/12 or 3/4 to me. Okay, this is 3/4 of a pizza, and that's 5/6 of a pizza. And they're going to discount it equal to the percent of pizza missing. What's the missing percentage of pizza here? Well, actually, I don't need to worry about it. I could just multiply this by 5/6 because that's my discount. They're going to give me a sixth off here and a quarter off there. This is 25% off. I don't know what that is as a percent, but I don't care. This is the price I'm going to pay. This times 20 plus 3/4 of a pizza times my discount times the cost of a pizza. Okay, so let's bedmiss this. 5/6 times 5/6 is 25/36 times 20. Okay, both of these are divisible by 4. So this is 5. This is 9 when I take out the factor 4. So this is, and then let's do this one. 3/4 times 3/4. This is, well, this would be 5, and that cancels one of those 4. So I'm done my canceling. This is 9. 9 times 5 is 45 over 4, okay, plus 125 over 9. Okay, so I'm going to get here 125 over 9 plus 45 over 4. Let's bring that over here. I'm just going to scale it up over here. So I'm going to have 4 over 4 times 125 over 9. I need to scale this fraction up by 4 to get a common denominator. Plus, and my common denominator, 36, plus 45 over 4, scale it up with a 9, 45 times 9 over 9, so 9 over 9 is what I scale that up with, over 4, okay? So this is equal to 4 times 125 is 500 over 36 plus 45 times 9 is 405. 405 over 36. Add them together. This is 905. Oh, it's the Toronto, one of the Toronto area codes, Mississauga, Oakville, that kind of places. 905 over 36. That is not divisible by 3. That is divisible by 4 and 3 and nothing else. So these don't share any factors. That's the fully reduced thing, but that's not an amount of money. You need a decimal approximation here. 905 divided by 36 equals, you pay $25.14. $25.14, folks, for your pizza. Okay, so I hope this walkthrough helps you prepare for the test tomorrow. And any questions, hit me up by email. Bye for now, everybody.